Welcome to school, mathematicians. We are going to do a addition vertically. We have one of the ugliest ducklings that I can imagine for a vertical addition equation, which has a lot of renaming in every place value I've tried to make it. So we have here 787 and 865. Now, before we start, we want to estimate. You can do this visually too by looking at the blocks. Looks like it'll be definitely more than 1,000. Looks like less than 2,000. But you can also do it by rounding. So you can go roughly 800. You could round that to 900, but I rounded that up. So I might want to round that down, maybe to 850. So roughly 1,650, we're thinking, roughly speaking. Then we actually will arrange these in their place values, and you've just got to excuse me throughout the video. I'll need to be arranging the blocks a bit, so I will have to put the phone down occasionally. So we're going to arrange the 865 at the bottom of the mat, the 787 at the top, just to match the order in the equation. And so there we go, 6 and 1 is the 7 and 5 is the dice. Try to arrange them so it's easy to see. So we're using our supertizing skills all the way up, just with bigger blocks. We've got 10s, the 80 I'll arrange as 4 and 4, and the 60 as 3 and 3. Then we've got the 800 here, the 700 here, and we've got our thousands place ready to accommodate what we know might happen, will probably need to happen, given that we have 700 and 800 involved. Then we're going to set it up vertically, traditional style, and get started. So 7 and 5. So for 7 and 5, we need to join these together. You'll just need to excuse my joining skills with one hand. These connectable ones do make it nicer to create the 10 than exchanging for a 10. I like them because they build a bit of trust in that it connects to make a 10. You can still sort of see the 10 ones, but then you can also see the 110. It matches the size of the 10's MAB. So we do tend to use these. Then it renames, 10 ones becomes 110. I like to put it at the top to match what the algorithm does. So it became 12, 7 and 5, 110, 1T for 10s, and 2 1s. The T is just a little add-on I've done for T for 10s. Then we have 8 10s and 6 10s, 8 10s and 6 10s, and 1 extra 10 there. So with the 8, I might get 2 from there and make it 10 10s. Then I'm going to get my handy little rubber band here. This will be extremely tricky with one hand, so I'm just going to rest you there for a sec on top of those blocks, and excuse me. And then I've rubber banded it so it looks like 100. You can also use these to sort of shape it before you did that. Stamp to check, looks like 100. So that renames to the hundreds place. 10 10s becomes 100. And this one joins the other 10s in the 10s place. So we have 5 10s and the other 10 10s that became 100. So the 8 and 6 made 14, the extra one made 15. 5 10s and extra 10 10s became the 100. Now we've ended up with 700, 800, and the extra 100 over there. We might grab these 200s to make 1,000. Again, I'm going to grab a rubber band and just rest you on the block that I'm not using. Apologies for a moment while I rubber band these 10 bulky hundreds. And that became 1,000 joined as 10 hundreds. It just sort of builds trust that the 10 hundreds becomes 1,000 without any exchange really needed. Then I like making these easy to see. That we've got 300s and 300s, 600s and another 10 hundreds. Let's check that. The 8 and 8 should have become 16. That matches what we got. 16 as 1,600 or 1,600s, 1,652. Check it back to our estimate. That looks incredibly close, so might give it a little smiley face or a tick that we think it's reasonable. And that's vertical addition with materials, old school way, but with MAB at least, so, or place value blocks, as we call them to the students, so it's a bit more modern. Now let's modern this up though. Let's change this up a bit. Might change to a nicer colour too, like pink. And let's try to make this a little bit more more efficient than the old school way, because obviously things have changed for the better in schools compared to this, and compared to the ruler whippings that I would have copped as a kid for sure. So hopefully things have changed for the better with our strategies, because we sure know society has changed compared to that. But in many ways, in some schools, we're still doing what we used to do back in the olden days in this way, and not much has changed, which is a bit of a shame. So let's see what we could change. So 865, 787. One of my favorite strategies that the kids love is the Nintendo Switch strategy. So I can see this is close to 800 here. So I'm going to switch some numbers across. I'm going to switch 13 across to make this 787, which is an ugly duckling, a beautiful swan. And to make it a beautiful swan, 13 makes it into 800. But that 13 has to come from this side. So that goes down by 13 to 852. Up 13, down 13, switch it from one side to the other. That just then becomes 800 and 800, 1600, and the 52. So much more efficient, so much more number sense. Better as a mental strategy than that. When you ask kids to solve things and then you can see them nodding their head like they're renaming in their head with columns, it's just so sad when they could be doing something like that instead. So that's called switch. Some kids call it the Nintendo Switch because we use the Nintendo Switch to model it, moving some blocks from the blue to the red side of the switch when we're first learning it. Bet you they didn't show that there. Another one can be the jump strategy. So for jump for this equation, you don't always have to, but I'm going to start from the 865 because the 787 is close to 800. So if I start from the 865 for my jump strategy, I can then just jump 800 to make it 1665. And then I shouldn't have jumped 800. I should have jumped 787. So I need to jump back by how much? Yeah, by 13. So if I jump back 13, then it becomes 1652, because take away 13 from that. So then that's my answer. Jump strategy, switch strategy. You can do the jump in other ways, but it's always better to do it as efficiently as possible. Don't make the kids jump 100 at a time, then jump 10s at a time, like 110, 110, 110. They're going to be there all day and they're going to go, this isn't efficient. I think I'll use that one instead. Whereas when it's done efficiently, properly with flexible partitioning, it's a much richer strategy. Now, one strategy I'm not sure will work well or not for this one because it's got a lot of renaming is the split strategy, but we can give it a go. So I'll rub these out for a sec. And now we'll try split. So split strategy involves splitting the place values. So 787 and 865. You can use a web format, which is the more popular version for most students. So often they start with the hundreds, which is the exact opposite of what we taught them with the vertical algorithm. Most mental strategies will start with the larger place value, which is why the vertical algorithm's almost contrary to what humans naturally want to do, which is to get rid of the big numbers first out of your working memory. So we'll start with the hundreds as per what you'd probably do mentally. 700 and 800, 1500, 80 and 60, 140. And then we've got the final 7 and 5, 12. We put that together, it becomes 1652. So 1652. You might think, oh, I'm going to start at the 1500, add 100, 1600, add 40, 1640, add 12. Or however you want to combine them. You might combine these just to get the small numbers combined, 152, and then combine it with that 1500. So it did actually work better than I thought it would. Split strategy sometimes doesn't when there's a lot of renaming, but I think I still prefer it to that as a split. Another way you can do almost like a split, but an expanded form split, 700, let's change to a better. So let's go 787, and then below it, you write 865. So you expand out those place values into their expanded forms. Then that becomes 12 and 140 and 1500. You can see the connection. It's basically split, just stepped out a bit more. And then you could add them in any way you like. Maybe this one, 152 and 1500 equals 1652. notice you have a better sense of a student's place value, genuine place value, with any method like this, or switch or jump, than you can get with this, which a lot of students can paper over their place value with a procedure or recipe, but they can hide their lack of understanding of place value. That's why this is so dangerous. It hides whether you really understand it or not. It's back in industrial age. Everyone's going to become factory workers packing boxes, so we just need you to learn to follow a procedure or a recipe, and then you'll be successful enough in life. That's obviously different to where we are as a society now. So that strategy may not be the best thinking mechanism, or the best way to inspire thinking in our students is the problem. It's definitely a strategy you might teach, but probably last, because some students tend to grip to it as a coping mechanism that hides their lack of conceptions or genuine number sense. So we did switch, we did jump, we did split, we did expanded form split, basically the same thing. You can also do round and adjust. So for that, we've got 787, 865, I'm going to call R and A, round and adjust. For this, it's similar to switch. I'm going to add 13 to that, and I'm going to, how could I adjust that one? Maybe, I probably don't need to adjust that one. And then I'll do 800 plus 865 is 1665, but then I added 13, so I have to take away 13 is 1652. You can see how it's very similar to switch. It just leaves the process at the end that you have to go back and adjust, whereas switch does it all at once. I generally think switch is safer. Sometimes students forget to adjust at the end. They just round but don't adjust. So I generally teach switch first, then round and adjust later. Round and adjusting is particularly valuable for multiplication though. You round it, you multiply it, then you adjust it back to what it really was. So that is the vertical algorithm, first with materials, but then with other mental strategies that could be very valuable alternatives to the vertical algorithm that I'd probably model first with materials as well. There's plenty of materials-based ways to model all those strategies. In our units, every unit's dedicated to a materials-based way to model those. We're in Warrnambool, so of course it's windy and rainy, so it's a nice day to be inside doing indoor maths today. Enjoy old school maths when you're up to it, mathematicians.